I did suggest, Bob, that maybe tonight we could talk about really what's meant by closest approach of these things and near Earth objects, because it's one thing having the headlines, but it's another. We don't want to be seen as being the tabloid scaremongering people.
That's right. Otherwise, we'll be known as crying wolf, and
yeah,
people
yeah. Okay. But obviously the closest approach and terms like that are official. It's not just us using those words.
All right. Okay.
Why isn't that screen share coming up?
Okay, show will start in about a minute and a half. A minute and a half will start up. Show will start in about 60 seconds. Hi everyone, this is Patrick Palucci with Slooh Space Camera. It is 1:30 on Thursday, October 4th. Hi everyone, this is Patrick Palucci with Slooh Space Camera. It is 1:30 on Thursday, October 4th. Apologize for that, my friends. It was a backfeed issue on my computer. Hi everyone, this is Patrick with Slooh Space Camera. It's Thursday, October 4th at 1:30 p.m. Pacific, 4:30 Eastern, 20:30 UTC, and we're here today with Bob Berman, longtime Slooh editor and Astronomy Magazine columnist, as well as Paul Cox, Slooh Outreach Coordinator, and we're here today to track a unique asteroid that's come into view. It's a near-Earth object classified. The name of it is 137032 1998 UO1. That's a long one today. It's just to give you a quick background on it. It looks like it's 1.8 miles in diameter, and it's at a relative velocity of 73,000 miles per hour. So wow, this thing's really zipping by. As some of you know, we've tracked asteroids out there. A lot of them that we've done in the past have been ones that are not expected. They've come into view just sometimes in days. So typically we don't track everything, but in some cases what we've done is we've actually this particular one is known. We know this one was coming in. It was discovered, I guess, in 1998, so we knew this was in its path. It's on its close approach today. And what Paul Cox is doing from our Canary Islands Observatory off the coast of Africa is he's just attempting to track it right now. So, Bob, why don't you give us a quick your quick thoughts on asteroids in general, and what's going on here as these things are zipping around the solar system.
Okay, we might as well start with the story's beginnings, which was the very opening day of the 19th century. Imagine that, Pat, the very first day of the 19th century when the first asteroid was found. And within a few years, 4 had been found. First, they thought it was a new planet, but there's more and more and more of them. It turns out there's 4 big ones. Biggest is Ceres, C-E-R-E-S, about 800 miles across, or more like 650 miles across. And the other big ones, Juno, Pallas, and Vesta, are a few hundred miles across. Now, since then, more and more were found. Some of them are only 1 mile, like this one. Some of them are 20 miles. There's thousands of them. And what we are concerned about, what we should worry about, are the rather relatively rare asteroid that crosses the path of Earth and that can actually collide with us. And so those are the ones that create all the near hysteria that have changed the life on Earth, really, that have erased dinosaurs, created mass extinctions. And so it's very important that we keep our eye on them. Plus, there's a lot of, for a better word, paranoia out there. People who are afraid that this one's going to hit us. Maybe the government is covering it up. And since we're not government run, although Pat is with the CIA, but he's allowed to talk about this stuff, we will bring you the truth. We'll show you the actual objects, and you can judge for yourself that they are safely missing us.
So, Paul, why don't you talk to us really quick about the feeds that we're looking at in the channels on the slooh.com homepage. And if you're watching this in G+, or if you're watching this in YouTube, the best presentation is really on slooh.com, where you can actually see our panel, the Hangout panel, as well as control the observatory feeds and actually pin photos and do some other stuff. We also monitor the Slooh conversation box that's on the slooh.com homepage. So you can ask questions to Bob or myself or Paul. So, but Paul, why don't you tell us a little bit more about the feeds we have, and I'll screen share in, or I'll click you over here.
Okay. Yeah, I mean, we know that some people can only watch on their mobiles the YouTube or Google Plus Live, so we always try and screen share the homepage as well. But if you are on the homepage, you'll see the first view. The live images are actually everything that's in that blue circle. And what we're seeing at the moment is the T2 HIMAG telescope, and we're tracking this asteroid at the rate that the asteroid is moving against the background stars. So what we can see here is a single point of light, and then all of the stars in the background are trailing. And this is good news for us tonight, because we were actually closed. The observatory was closed because of high humidity, and literally we didn't have a chance to test this. So we've got that asteroid almost bang center in the T2 HIMAG view. So that's going to carry on moving, and from each image to the next, we're going to see that small white dot moving further and further. Over the course of the show, it's going to go through a full field of view of that particular telescope. Then we've got the half-meter telescope. Now, I've done something slightly different with this tonight. I'm not tracking the asteroid, and I'm not even centering the asteroid in the image. I'm taking the same star field in every single image that we see tonight, so that what we'll see, and we might only be able to do this after the show, but what we'll see is the asteroid moving position in each particular image. So that'll be an interesting one for us to try tonight. In the T2 wide field tonight that we've got, there is actually an object there that has appeared as a dotted line. I'm not convinced that would be this asteroid. I think that's probably a bit too long, so that we may have just picked up a satellite or something like that there. And of course we've got the all-sky view, which we're having to keep a really, really close eye on tonight, because we've got a lot of cloud just below the base of the observatory, which can kind of blow up the mountain and engulf the equipment. So we're having to keep a pretty close eye on that. But probably tonight the T2 HIMAG view is going to be the best one, and we're running a lot of these for this asteroid and the other one later, and we'll pop those into a bit of a time lapse later on.
So if you're on the home page or looking at the T2 HIMAG view, that dot that you see among the trailing stars is the asteroid itself, and Paul is actually tracking this thing. It's 1.8 miles, think about that, in diameter, so that's pretty big, and it's traveling at over 73,000 miles per hour. So, Paul, just curious, how do you even track something that's going that fast?
Well, it's although it's going that fast, its relative velocity, in other words, what it looks like in comparison to the background stars, the tracking is not that much greater than the Earth rotates. As you can see, if all of those stars were perfectly round, then that's how the telescope normally tracks. And you can see, these are what, 60-second exposures, something like that, and that's how far really the asteroid is moving against the background stars. Now, the one later on that we're doing in a few hours' time, what's that, in 5 hours' time or something, 5.5 hours' time, that one is a lot smaller than this asteroid, but the reason why I picked it, they're both making their closest approach to Earth. The one later on is a lot closer to us, therefore it's going to be moving against the background stars a lot faster. So that one, the telescope mount actually has to move at quite a different rate to normal.
Right. So Bob, as we look at this asteroid, and as you know, we've covered a bunch of them in the past. I think one of the things that always blows me away is there's so many of them zipping by us on a daily basis, really. And have you shown any concern though? But lately, it seems like we've discovered 3 or 4 of them that just have kind of popped out of nowhere, and they've kind of come somewhat close to us. How is this because of lack of funding, or is this normal on any given year? Are we going to get a lot of asteroids or comets coming into view, or that we didn't expect?
Well, actually, it's the other way around. In the recent years, there have been more facilities that have been looking for near-Earth objects and asteroids that can pass near us. So because we're looking more and the equipment is set up for it, we're finding more. It's a little disconcerting that we're dodging bullets here and there and there and there. Fortunately, we never used to know about them. I would like to point out what damage would be done when one of these hits us. Now, it's not a question of if, it's a question of when. Could be tomorrow, or it could be a million years from now, because these things
or it could be on
do
December 21st.
Let's hope it's not December 21st. That's the last thing we want, because then they'll all say, "See, we told you so." So here's a little
Right.
quick primer on how to know what kind of damage it is. Size really matters with these things, because not so much because the heavier it is, obviously, the more damage there'll be, but this is why, Pat. The heavier it is, the faster it can come in. And that's because our atmosphere will slow down incoming objects, but only if they weigh less than 60,000 tons. Now, 60,000 tons is close to a small cruise ship. So think of that in terms of size. If you have a mass smaller than that, our atmosphere will slow it to terminal velocity, which is why your normal meteor that comes in, if it does land as a meteorite, you know what speed it lands at? It started out at 20 miles a second or so, let's say about, which would be about 66,000 miles an hour when it came in. But you know what speed it ends up hitting a roof or hitting your lawn? Only 250 miles an hour. Our air slows it all the way down to that slow speed, 250 miles an hour, enough to make a little indentation in your lawn or break through the roof of your house and maybe go through one additional floor. This has happened, and it happens every few years. A house here in North America gets struck every year and a quarter on average. And the rock, the piece of the asteroid, and they are asteroids, not comets that are coming in, do manage to go through a roof and one more floor sometimes, but no further. But now imagine if it had more speed, because the kinetic energy, the impact force, is a function of mass times the square of the velocity. So the velocity is super important. Now, if an object weighs more, it'll manage to overcome the air resistance a little bit more, but the key figure is 60,000 tons. Because if an asteroid weighs more than that, as I said, it just has to be bigger than a cruise ship, as this one is, and then our atmosphere doesn't slow it down at all. And it comes in at full cosmic velocity. Pat already mentioned that this one's traveling at 73,000 miles an hour. That's roughly 20, perhaps 22, 23 miles per second, which means it's 50 times faster than a high-velocity rifle bullet. If something weighing as much as Well, if it's a mile, 0.8 in diameter, this is a very high mass object, comes in at that speed. This is major damage. This could easily destroy not just one city, but a whole region of Earth. So it becomes a very serious business when you're dealing with objects of this kind of mass. Mostly for the extra speed that they'll impart rather than their extra size.
Right. So, Bob, I was going to monitor the chat, the Slooh conversation section on slooh.com. Just a quick note that membership to Slooh helps fund our free programming that we do on the homepage here. So please consider membership. If you just click on the link on the top right, and but the main benefit of membership is you actually get to control the telescopes that Paul is controlling right here, and Slooh makes it very easy for newbies, and we also have advanced tools for guys who know what they're doing on the FITS level and want to do some advanced types of imaging. And we have our facility out in the Canary Islands. It's a world-class facility. You're able to snap pics, share them with your friends and family very easily, and it's a great program. We've been around since 2003, so we've got a robust worldwide membership base. So please do consider that. We do have an iPad app coming out in about a month, and it's going to be really, I think, a groundbreaking app. It's going to allow you to one-touch control robotic telescopes right from your iPad, as well as give you a whole view of the night sky, which is going to be really neat as well. So anyway, there's a question here in the conversation box. I'm going to start looking at it. It says here, Bob, if you were to go outside, can you see the asteroid, or is it not visible to eyesight?
Oh no, this asteroid is far fainter than the planet Pluto is. It's probably 60 times fainter than Pluto. Paul, what magnitude is it exactly, this one?
16, just over
okay,
16.
So Pluto's about 14, so this makes it 6 times fainter than Pluto. And in terms of what even a good backyard telescope could show you, which goes down to perhaps the 11th magnitude, we're talking about 5 magnitudes fainter, which happens to be 100 times fainter. So let's put that all together. It's 100 times dimmer than the faintest object you could possibly see in a good backyard telescope. So not even close to being able to see this naked eye.
Plus, it would be pretty... Oh, go ahead, Paul.
So just one of the interesting things, and the other reason why I picked these two, they are, as I say, both making their closest approach tomorrow night, is that the other one is a great deal smaller, but because it's so much closer to us, it's actually the same brightness. So it's going to be looking roughly the same, but it will be moving faster, or look as if it's moving faster.
Oh, that's wild. That is wild. Yeah. So Bob, what's the story of comets and asteroids bringing life to Earth? I mean, what's the theory on that? Is that how we still think that life came to Earth, is potentially from a comet or an asteroid, or what's the whole story behind that?
Yeah, that's new thinking, because if you open up a textbook from 30, 40 years ago, the idea was Earth is an island in this vast ocean of space, and life somehow evolved here independently by some magical means. Nobody knows how, and nobody still knows how. But the new thinking is, since we found that there are amino acids, those are the building blocks of life, in comets, and we have found simple amino acids even in asteroids, it means that these, at least the precursors to life, may have been transported here. Maybe they roam the universe, and when they land on an object in a kind of stasis, or in a form that, once conditions are right, they can flourish. And we'll know if this is true or not in a few years, might be more than a few years, when we analyze the ocean water that's in the moon, under the ice sheets of the moon Europa, because this is a perfect petri dish for life. And if there is not life there, because Jupiter has had all these asteroids and comets hit them just as we have, then we're going to have to revive our thinking and consider that life is a much rarer thing than we've imagined. But if I had to bet, I'd say we'll probably find life there.
You know, it's interesting, Bob. Why would we find life more on a planet like Europa, moon like Europa, as opposed to Mars, which seems like it's closer to the sun, and it would seem like it would be a better candidate for that?
Yeah, well, that's a good question. See, in the old days, we were so ethnocentric in terms of where we thought life would be found, that we imagined that it has to be a planet sort of like Earth. The nearest planet that's sort of like Earth to us is Mars. Now we know that because it has almost no atmosphere, it's hit by harsh ultraviolet rays, it's not protected, it has no magnetic field, it gets full radiation from the sun bombardment, that if there is life on Mars, it would have to be underground. So let's open up our thinking. If life could exist underground, and it does here, then maybe we shouldn't think that being near the sun and being warm and comfy is important. Perhaps life is more common under the surface of objects than above the surface. After all, life started here on Earth under the surface of the ocean. So perhaps oceans, and we've only known about oceans for a few years now, perhaps saltwater oceans are the way to go and the most likely abode for life.
Wow. So if you're just joining us, we're looking at live views of Asteroid 1998 UO1. It's about 1.8 miles in diameter, and it's traveling at about 73,000 miles per hour in relative velocity. And we're here with Bob Berman, longtime Slooh editor and Astronomy Magazine columnist and author. And Bob, I'm going to actually promote your book even on this show today, The Sun's Heartbeat.
Bless
I always
you.
do this for Bob. It's a great read, and Bob, if anyone's read him in his magazine articles in Astronomy Magazine, you know he's a great writer. We're also with Paul Cox, Slooh Outreach Coordinator. He also is manning our observatories in the Canary Islands to give us these views. So, Paul, thank you very much for doing that. It's great. We are also going to be doing another asteroid show this a little bit later tonight. That one is going to go down in about, I think it's 7 p.m. Pacific, 10 p.m. Eastern, 02 UTC. Paul's going to helm that one. It's a quick one, about a 20-minute show. Paul's going to come back on and show that to you live. So we're looking forward to that. But tomorrow, Friday, we're also doing a Moon and Jupiter conjunction show live. And that one is going to start at 7 p.m. Pacific, 10 p.m. Eastern, 0200 as well. And we're going to give you some really cool dialed-in views of Jupiter, along with the Moon. They're kind of technically in conjunction, so it's going to be kind of neat to see. But Paul, I'm hoping you can fire up the other observatory or other telescope we have available to us to give us a dialed-up view of Jupiter. That would be really cool. Bob is maybe going to join us, or he's going to come in a little bit later after the beginning of the show, I guess. Right, Bob? Is that how we're planning that one?
Yes, that's right. I hope to get on at maybe 5 after 10 o'clock Eastern Time. I'm very excited about that because Jupiter's returning. It's one of our favorite objects at Slooh. And the fact that it's meeting the Moon in the sky, this should be a dramatic event for anybody who just looks up tomorrow night.
Exactly. So it'll be fun, too. We always like doing Jupiter, like you say, so it'll be a good time. We have about 10 minutes left in the program for today on the first asteroid show. If you guys have any questions, just go to the Slooh conversation box on slooh.com, and we'll try to answer any of those questions before we get off. So, Bob, what else could you tell us about asteroids in general? I mean, tell me this, is that maybe Paul can help me with this too. Is there like 9,000 plus near Earth asteroids circling around us at all the time, or are those potentially hazardous asteroids?
Actually, I think the current tally is something like 1,300 potentially hazardous asteroids at present. I only looked at that yesterday, so that is from memory, but I think that's the right amount.
And they're all, what originally happened, Pat, we think, is they're all going around the sun. But originally, all asteroids were confined to between Mars and Jupiter. But between collisions with each other that have changed their orbits, and which has made some of them pass closer to Mars, closer to Jupiter, it's like a game of billiards. And some of them have been knocked into new orbits where they now, unfortunately, cross our paths.
So
32 out. It's actually 1,332 potentially hazardous asteroids. But of course, that's only one subset of this larger group that we're looking at tonight, which are near-Earth objects, which comprise not only of asteroids, but also of comets as well.
And of course, there's still a lot of... I'm sorry, go ahead.
No, I was just going to say, why are they labeled potentially hazardous? Is that because they could get knocked off their orbits and hit us eventually, or what's the thinking on that?
My interpretation of that was, I think it was slightly different to Bob's, was that it has to do with their size and the proximity of their orbit. In other words, it could not be guaranteed that a slight change to its orbit would potentially bring it into the path of Earth's orbit. Bob, what's the official one?
No, I would say that's exactly what I would have said. I think that's exactly right. And we used to not worry about them because there's a lot of space up there. That's why it's called space. Although, in the most recently, Paul, I don't know if you've seen my current article in Astronomy magazine about infinity. We've never gotten so much mail about it. It's just pouring.
I have it, but I haven't read it yet. So.
Oh, but you must see that because it's flooding in, because apparently an infinite universe is really getting everybody intrigued, and I'll stop talking about it because it has no relevance to this, except to say that we used to think we have a lot of stretching room, a lot of breathing room. Why worry about them? They only come in every once in a while. We almost had our life on Earth obliterated 251 million years ago, probably by an asteroid, although there's some other theories. We certainly got hit by the one that plummeted into the Chicxulub region of the Yucatan 65 million years ago. That completely destroyed the dinosaurs and gave rise to us mammals. So that's the reason we've got humans and sitcoms and rats and all the nice things that we have today, because of an asteroid. And so we're now thinking that we're not isolated from the universe, that these things are part of our evolution, for better or for worse. And just to make sure it's not for worse, Slooh's going to keep watching out for them and bring you them, and assure the people who are worried that the government is lying to us, which it isn't. But those of you who fear that, will prove to you that these asteroids are where they say they are.
Exactly. We got about 5 more minutes left in this program.
Pat, can I just show you something quickly?
Yeah, go ahead.
I'm going to screen share in the images that we've had on the T2 wide field system so far tonight, and just flick through them. And we've actually caught it in all 3 telescopes tonight. But here it is. Here's the main image, and here's the asteroid here. These streaked things in the background are the background stars. And if I flick through these one by one, you can see how far it's moving in relationship to the background stars. So it's roughly half the field of view tonight that's gone through. On the other images, if I just screen share something else for you, we have picked it up in the ½ meter. And if you remember on that one, I've said we've done it a little bit differently. Let me find the right window. There it is. Yeah, we've done it a little bit differently. We've been taking an image of the same star field in the same position. So the asteroid, actually, I hope you can see this in screen share, is just this really pale line. And actually, let me get rid of these little windows here. And if I flick between the next image, you can see, hopefully, that line then moves over to here, where I'm putting my cursor in the Hangout.
Right.
So we've actually picked it up in both scopes tonight, and we'll do the same thing tonight with the asteroid tonight that we're looking at.
All right, that would be great, Paul. That'd be awesome. So, guys, we're down to the last 4 minutes. As I've always said in all these shows, please consider membership. It does support all the free program we do, but the benefit is you obviously get access to all the observatories that Paul's currently controlling, and we have a robust membership-based worldwide. We've been around since 2003, and it really does help us with these programs. Our goal is to start producing more of these on a weekly basis, although in the last 20, 30 days, we've done one almost every day, believe it or not, which has been pretty amazing. But Slooh has patented imaging technology that basically brings astronomy to the telescope within 5 to 10 minutes. Anyone who knows how to use a telescope knows the difficulties with them, and one of the cool things that Paul brings to the table is he helps explain to us how difficult it is to image something out there, for those who don't know, and how much money you'd have to spend, how much time you'd have to spend to do it. And what Slooh does is it actually helps you do it a lot quicker and with a lot less money. So please do consider membership to help both the funding of the free shows, but also the opportunity to take your own snaps and control our scopes. Bob, I appreciate you coming on as always. Our next show with you, and hopefully you'll come on as soon as you can on the Jupiter show tomorrow night. That's going to be at 7 p.m. Pacific, 10 p.m. Eastern. Paul's next show is tonight. He's going to be back on also at 7 p.m. Pacific, 10 p.m. Eastern. You can see these shows always counting down on the Slooh.com homepage. So if you forget the timing, just return to Slooh.com and you can see them counting down at any time. And I have to tell you, the schedule is always updating. So we're never, we put stuff in and then they get refined depending on weather and all the other things that are factor into this. So please do keep coming back. Or you can obviously follow us on Twitter, G+, or Facebook, and we'll keep you notified through those means as well when shows are occurring. We do put out posts and events and stuff to keep you updated as well. So that'd be great. We do have one last question, I guess, that was in the Slooh conversation section. Is the Orion constellation opened up? Bob, is it viewable right now? Do you know?
Yes, it rises. Yes, the Orion rises at about 10 o'clock at night, and then it's out all night long after that. It's
high. It's high enough to image for us at the moment. In the second half of the night, there's a few members tonight have scheduled the Orion Nebula and also the Horsehead and Flame Nebula. And member Dave Larkin very recently has done a fantastic mosaic. He's controlled the Slooh telescopes in the Canary Islands, taken a whole series of images around the Horsehead Nebula and then combine them all together, and it's an absolutely stunning image.
Yeah, I'm gonna I'll post that one out there as soon as we get through some of these shows, because I definitely want people to see that, because it is amazing what guys are doing with the FITS program and having access to the half meter like that. They can do these cool mosaics. I mean, it is neat what he did. All right, guys. Well, I don't have anything to add. Bob, do you have any last thoughts before we get off?
I just wanted to mention once again, if anybody is new out there, hasn't been here before, that it's so cool that we're not only looking at objects far away from Earth, but the Slooh people bringing this together are Pat in Southern California, Paul sitting in England controlling a telescope on the Canary Island, and me here in upstate New York. I'm going to swing the camera just to show you what is going on outside my window right now. This is October in the mountains here of upstate New York, and so it's just one of the glories of this beautiful universe that we're living in.
Yeah, Bob, one of these days I'm going to have to post that bear video you showed us. That was pretty funny.
Yes. I sent that. Yes, do post that of a bear breaking into my garage and me running out and chasing it away after it made a hole and was lurking in the garage.
Right. Well, I don't have wild bear problems. I got wild cat problems. That's my problem. I got wild cats attacking my yard. It's a long story, but anyway. All right, guys. Thanks for coming on, and we'll see you later. Paul, good luck tonight, and then guys, we'll regroup tomorrow for the Jupiter Moon show.
Thank you. Okay.
All right, guys. Good night.
Good night, everybody.
For Slooh Space Camera, this is Patrick Palucci. Good night, guys.
I did suggest, Bob, that maybe tonight we could talk about really what's meant by closest approach of these things and near Earth objects, because it's one thing having the headlines, but it's another. We don't want to be seen as being the tabloid scaremongering people.
That's right. Otherwise, we'll be known as crying wolf, and people
yeah. Okay. But obviously the closest approach and terms like that are official. It's not just us using those words.
All right. Okay.
isn't that screen share coming up?
Okay, show will start in about a minute and a half. A minute and a half will start up. Show will start in about 60 seconds. Pluto Slooh space camera. It is 1:30 on Thursday, October 4th. Hi everyone, this is Patrick Pluto Slooh space camera. It is 1:30 on Thursday, October 4th. Apologize for that, my friends. It was a backfeed issue on my computer. Hi, everyone. This is Patrick with Slooh Space Camera. It's Thursday, October 4th at 1:30 p.m. Pacific, 4:30 Eastern, 20:30 UTC. And we're here today with Bob Berman, longtime Slooh editor and Astronomy Magazine columnist, as well as Paul Cox, Slooh Outreach Coordinator. And we're here today to track a unique asteroid that's come into view. It's a near-Earth object classified. The name of it is 137032, 1998 UO1. That's a long one today. It's just to give you a quick background on it. It looks like it's 1.8 miles in diameter, and it's at a relative velocity of 73,000 miles per hour. So wow, this thing's really zipping by. As some of you know, we've tracked asteroids out there. A lot of them that we've done in the past have been ones that are not expected. They've come into view just sometimes in days. So typically we don't track everything, but in some cases what we've done is we've actually this particular one is known. We know this one was coming in. It was discovered, I guess, in 1998, so we knew this was in its path. It's on its close approach today. And what Paul Cox is doing from our Canary Islands Observatory off the coast of Africa is he's just attempting to track it right now. So, Bob, why don't you give us your quick thoughts on asteroids in general and what's going on here as these things are zipping around the solar system?
Okay.
Hi everyone, this is Patrick